Hello everyone, this is 3D printed animatronic creature part 24 gimbal rotation test. Wanted to show you the process on how I change out the servo for the rotation of the whole head with the so-called chest piece in place. The large block below it is something I've been working on, just kind of like, it's going to probably be a wooden block, something nice, just to support the whole thing. But as you see here, this is the Servo City servo block, and this Gobella servo is going to be used for this servo block because this servo block is made for this servo. But as you see here, this is how I'm going to be mounting it. And that large block is going to be attached because I don't want this, the animatronic's going to be somewhat top heavy, and I just want it to be stable, but this is later on, but just to be able to support it instead of the vise. But this piece right here is the hub that I chose. Now this is a wheel hub, but I like it because it had a straight axis for this beam, and what this is, that this is going to be sandwiched to the servo sockets that this is going to be rotating to. So it has to be center to the beam, center to the hub, and center to this servo hub to the servo block. And these beams support the so-called chest piece, allowing it to rotate within that chest piece area. And since I'm having to change this servo block, I had an older servo block, and it was Imperial, and it was, probably a few years old, and I ordered this one, and this way I could get everything back metric, and I really prefer metric over Imperial, and they mostly discontinued all the Imperial things at Servo City anyway. But this is what I got, as you see here, and this is the setup with this so-called new servo block. But a servo block is really good, and it's unusual how it supports the so-called servo in a aluminum or aluminium kind of a servo socket bracket, and it has a bearing. But before I can get into it, and y'all see it later, but I have to take the old one apart, and I can just show you how I'm having to do this. It's fast speed, so you can watch and enjoy this. But the servo block is really cool. I wish a lot of servos would make these. I mean, this is a patented, design from Servo City, but it's just really, really important how you can protect and give the so-called servo horn support with a bearing. And you can, in designing servo or animatronics, you really need, you can't put a lot of weight on a spline or the axis that rotates on a servo, and you can damage a servo if it's not done correctly. And this just helps on designing certain animatronics. But this is me showing you, this is the old servo block, and I'm just taking it apart, just taking just basically everything down to where I can transfer it to the new servo sockets, and then I can reduce the size of this so-called this whole beam area. And as you see here, I'm just having to, there's a lot of screws in this so-called design here, and it's much, it's bigger being so-called Imperial, and I've had to use these extra beams just to be able to lay it onto this older servo block. But this hub that I'm putting on the end of this beam here is a hex hub for wheels. And you get two, but I only needed the one. But as you see here, I can make it where this will be center axis to the servo spline. onto the so-called mounting it sandwich this whole piece here to the servo socket blocks that hold the servos for the tilt mechanism. And here is the new servo block using this servo here. And I'll screw this in place, but I'll make them loose. But then I'll put the servo horn into the bearing and connect it to the servo spline. That way I can center it correctly, and then I can just finish tightening the screws in place. But I've been working on other things too. I have a baby animatronic, and I've been working on also a large animatronic head, and been redesigning the jaw for it. But as you see here, it's a quite simple device on this servo block to put together. And as you see here, I'll compare it to the old one, and see the old one. It has a servo. That servo there is a high-tech servo, and its tooth is, or the spline is a 24-tooth spline. And most servos today are, the spline as far as a standard servo are 25 tooth, or a T25 they call it, and that's the most common servo horn. But as you see here, it's working. It just makes it so much more fluid, and I'm really happy with this design, being the size. And they have those screw points on the side there and on the top, all the way around basically, and it's all metric, and these are threaded, so that helps putting things together. But all these servo blocks have this, and it's just really a good design, and I'm happy to use them. But this is a pretty cool device right here. I wish they would make mini versions of this for mini servos. But as you see here, I can just pull this servo horn off. Now you can screw this down, connect it to the servo, but at this time I want. And in this case, I might not really need to, but because it's going to be always, um, standing straight, but you can, but I would redesign the so-called uh, beam situation so I can place a screw there and then lock it in place. But as you see here, I'm just sandwiching this so-called this beam and the servo sockets where I have the tilt mechanism, and it just fits on this block, servo block, correct. And then I can demonstrate it here. As you see here, the rotation is nice and fluid, and this servo here doesn't really have a whole lot of what they call uh, the pulse. Sometimes on the cheaper servos they have a pulse, and it kind of skip during the rotation. But here I'm attaching beams so we can connect the chest piece, the covering of these tilt servos, and the rotational servo. Now these beams, there's a hole every 8 millimeters center, and the end of the beams is threaded. So these are cool designs too, and aluminum's lightweight and it helps in design. And sometimes you will need beams to support 3D prints, and when you have a lot of 3D prints, you don't want to make it too fragile, and this will just add support to your animatronic design. PCBWay contacted me about doing advertisements, and I thought that was pretty cool. And they have a printing service where they print in all types of materials, and they also print things in metal. And uh, one of the things I would love to do later on in another project is do a small animatronic again, but have it printed in aluminum or aluminium. And I just think that would be so cool to have one in a version of all metal. And then the thing about doing that is it wouldn't be 3D prints. It would be, I'd have to design it to where it would be where I could put threaded into the metal pieces. That way I could just bypass nuts and just do straight screws into the, screwing in the, the servos and their sockets and just bypass nuts, altogether. But that would be a neat animatronic to just be all metal. But as you see here, I've transferred everything to this new, this whole gimbal. And another thing I've been also considering is cutting down some of this chest piece even more to make it maybe more narrow to where, see, this is what I'm also thinking, that I'm going to be adding skin to this, and then I'm going to have to design skin to cover this chest piece. Well, the more area that I'm going to have to cover is going to be more silicone. And the more silicone, or the large of this so-called mask skin area coverage of this animatronic, is going to make the mold bigger. And if it's going to be bigger, it's going to be more supplies. And to keep costs down, I'm willing to sacrifice some of this, just to keep everything small enough so we can all afford this. Because silicone is a quite expensive material. I mean, it's come down in price. It used to be a lot more expensive than it is today. But once again, I'm just trying to keep costs down for y'all so y'all can understand on building something like this can be quite expensive, even though, this servo head has 8 servos in it, and I've gotten the servos down pretty low, and I might make even more adjustments to this, the gimbal servos. Uh, I'm trying to locate everything to where it'd be easier for y'all when y'all build this so-called animatronic that I'm designing for y'all, to where y'all can afford these and also be able to get them easy. But once again, on this so-called head, I was still having trouble with the mouth or the jaw neck. And what I noticed is I did put the jaw servo backwards, or it was upside down, so I had to flip it, and then I had to do another linkage. But once again, I got the servo flip in its right position, and then just added the correct linkage length, so I wouldn't keep getting a backlash or a whiplash. Where sometimes if it extends too far and it folds onto its further hinge point, you'll get this so-called fold, and it won't work correctly. And that's just in part of the designing of it. You try to keep them short as you can, but if it's at a longer distance, your linkage is going to have to be long. But I got it working. It's working good. I'm happy with it. But now I'm going to get ready to connect it to the gimbal, and I'll do a gimbal test. But I like the opening. It's going to be open and wide. But once again, when we get the skin on, it's going to be really cool. And then we'll have the lips to move, and to where we can open them lips up and see the teeth. But as you see here, I got the new gimbal all ready and set up. But now I got to mount it back to its neck location on the beam. Now, to hold this in place, I use this little, it's a milling vise, and you can pick these up, and I like them because I can kind of, hold my servo, because this, it's just standing on the servo right now. And this is where I was designing that so-called block. And that block would just inset inside that block and hold in place, because once again it's going to be top heavy, and with this mechanical head moving all over the place, it's just going to be more likely to want to teeter, and I gotta design that support the whole animatronic. But I have this in place, and as you see those metal parts on the top, that's the neodymium magnets to hold the skull in place, skull lid. But here's the first movement test. I was just testing the movements as far as the tilting, and I do some rotational movements also. And again, when we get the skin on there, it will act like a what I call a tension spring, and that way we'll get rid of the mechanical wobble. And you'll have that if you have anything of a large structure mechanically. It kind of has this so-called mechanical wobble to it, but once we get the skin on it, a lot of it's going to be clean. But as you see here, here's the movements I did straight on with the camera, and I'm really impressed with it. And with the servo that I have, the new servo on the bottom there with the rotational, you can kind of see it. Now I am controlling this with the RC radio, and I'm going to demonstrate that in a minute. But just to show you the rotation and the fluidness of it, and it will also look a lot more fluid when I hook it up to the computer, because the computer has a different kind of, I guess, a format, and it controls it more fluid, and plus I can mix it better than I can here with the radio. But as you see here, it just gives it a little bit more life, more expression. But next, what I'm going to be doing is I'm going to reconsider maybe doing some design changes to the chest piece to narrow it down a little bit. Once again, I'm trying to keep costs down, and this is about 250 millimeters tall, and trying to keep it small enough so the cost of materials to molding and casting this will be lower also. But once again, I appreciate all y'all. Thanks for all the subscribers and all the comments, and I'm really glad to share this with y'all, and hope y'all helps y'all with y'all's future designs of animatronics. And I mean, it's really fun to do, and it's a really good achievement. But once we get skin on it, now we're going to look at core. We're going to look at just getting things ready to make the skin and get this process finished so we can see it move and come to life. I hope y'all like. Thanks for everything, all the thumbs up and comments and the subscribers. Later.